Welcome to Ask and Learn.
All right, so here we are given that f is equal to x squared, and of course this is part A, and g is equal to x cubed, right? And so we want to take the limit as x goes to infinity of f over g, okay? So this is equal to x squared. I'm getting a little ahead of myself. This would be equal to the limit as x goes to infinity of x squared over x cubed, which is equal to the limit as x goes to infinity of 1 over x. And we just we're able to take x squared out of the numerator and denominator there. Okay, and this is equal to 0. So by the definition of little o, we know that x squared is indeed little o of x cubed. So to part B, we want to do the same process. New functions though, so we have f is equal to x times the log of x, and g is equal to x squared. Okay, so again, we take the limit of the ratio, so as x goes to infinity, of f over g, so that's going to be x times the log of x over x squared, and we can take an x out, right, of the top and the bottom here. So if we take the x out of the numerator and 1 out of the denominator, we get the limit as x goes to infinity of the log of x over x. Okay, and then we're going to use L'Hopital's rule. So we're going to take the derivative of each of these and know that the limit will be the same. So the limit as x goes to infinity of 1 over x over 1, which is equal to the limit as x goes to infinity of 1 over x is equal to 0. Okay, so then by little o notation, we know that x log of x is little o x squared. So for part C, same process, new functions. We have that f is equal to x squared, and g is equal to 2 to the power of x. So we want the limit as x goes to infinity of f, which is x squared, over g, 2 to the power of x. Okay, so we'll use L'Hopital's rule. We'll get that this is equal to the limit of x going to infinity of 2x over 2 to the power of x times natural log of 2. Okay, well, we need to use L'Hopital's rule again, right? So this first time was by L'Hopital's rule. Here, this is also by L'Hopital's rule. So we use it the second time. We'll get that it's the limit as x goes to infinity, this time of just 2 for the numerator, and the denominator is 2 to the power of x, and then the natural log of 2 squared. Okay, well, so the natural log of 2 is sort of inconsequential. The 2 to the power of x is going to usurp it, and the limit of that is infinity, right? So we're getting 1 over infinity, which is 0. So by definition of little o notation, we know x squared is indeed little o 2 to the power of x. And lastly, part D, we get two new functions. F is equal to x squared plus x plus 1, and g is equal to x squared. Okay, so we take the ratio again and the limit. So the limit as x approaches infinity of f over g is the limit of x squared plus x plus 1 over x squared. Right, so we can break this up. This is going to be equal to the limit as x goes to infinity of x squared over x squared plus x over x squared plus 1 over x squared. Okay, well, this is equal to the limit as x goes to infinity of 1 plus 1 over x plus 1 over x squared. 1 over x and 1 over x squared are going to be equal to 0. So this is equal to 1. But uh-oh. So by a little o notation, f is not little o of g in this case. So this big polynomial, well, not that big, but